This lesson shows how to use matrix algebra to solve two-variable linear systems. The first step is to write a matrix equation that is equivalent to the linear system. The coefficients of the variables from the left side of the two equations are entered into the coefficient matrix. The variables are entered into a variable matrix, and the constants are entered into a constant matrix. This matrix equation has the form AX equal B, a coefficient times a variable equals a constant. In the previous lesson, you learned to understand that the solution to this matrix equation is the inverse of the coefficient matrix times the constant matrix. So the next step is to find the inverse of the coefficient matrix. For a 2 by 2 square matrix ABCD, the inverse of the matrix is given by this formula. The formula is a number times a matrix. The number is 1 over, or 1 divided by, the determinant of the matrix ABCD. Recall that the determinant of a matrix is the product of the main left to right diagonal minus the product of the other diagonal, or A times D minus B times C. The matrix is a rearrangement of the original ABCD matrix. On the main left to right diagonal, the elements have been switched. Instead of A and D, it's D and A. On the other diagonal, the signs of the elements are switched. Be careful here. Negative B and negative C don't mean these elements are always negative. Negative B and negative C means to change to the opposite sign, plus to minus, or minus to plus. Here are some examples of how to rearrange the matrix. For this matrix, the main diagonal is switched from 4 and 1 to 1 and 4. On the other diagonal, positive 2 and positive 3 are changed to negatives. For this example, the main diagonal is switched from negative 2 and 5 to 5 and negative 2. On the other diagonal, plus 6 is changed to negative 6, and negative 1 is changed to plus 1. Going back to the formula, the number in front of the matrix is 1 divided by the determinant of the original ABCD matrix. Realize that if the determinant is 0, since division by 0 is not defined, the inverse of the matrix is not defined, which means the matrix equation has no solution, and therefore the linear system has no solution. So, if the determinant of the coefficient matrix is 0, the linear system has no solution. Now, go back to the matrix equation and use the formula to find the inverse of the coefficient matrix. The first step is to calculate the determinant of the coefficient matrix, which is 4 times 1 minus 3 times 2, which gives 4 minus 6, and the determinant is negative 2. So, substitute negative 2 for the determinant. the next step is to rearrange the coefficient matrix. The coefficient matrix starts out like this: 4, 3, 2, and 1. Switch the elements on the main left to right diagonal. 4 and 1 from the original matrix become 1 and 4 in the inverse matrix. Then switch the signs of the elements on the other diagonal. 2 and 3 from the original matrix become -2 and -3 in the inverse matrix. Now you have the inverse of the coefficient matrix. Go back to the matrix equation and substitute the inverse of the coefficient matrix. Calculate this product to find the solution. If you start with the scalar multiplication of 1 over -2, you're going to have to deal with fractions in your matrix. So don't do that. Instead, begin by multiplying the two matrices for 1 times 19 minus 3 times 9 in the first row, and -2 times 19 plus 4 times 9 in the second row. These rows become 19 minus 27 and -38 plus 36. 19 minus 27 is -8, and -38 plus 36 is -2. Now, when you do the scalar multiplication by 1 over -2, -8 divided by -2 is plus 4, and -2 divided by -2 is plus 1. So the solution to the matrix equation is x equals 4 and y equals 1. And therefore the solution to the linear system is x equals 4, y equals 1. Make sure you check this solution. To summarize, to solve a linear system with matrix algebra, begin by writing an equivalent matrix equation. Find the inverse of the coefficient matrix, which comes from a formula, then multiply times the constant matrix. This product is the solution to the matrix equation, which is the solution to the linear system. Be sure to check your solution. This lesson is brought to you by the Math Fun Academy. Its continuing mission to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.